Hello and welcome to Static Assert is almost all you need, but we will try to verify that claim. Level 0, who is writing tests? So far so good. Level 1, we have a constexpr function, or not a constexpr, but we constexpr all the things by default. In GCC that's actually possible. And we do static asserts. Level 1, anyone? Okay, we have 3 more levels to go. Actually, 42, sorry. Level 2. We would like to put more things, like common things into our tests. We can do that by having a immediately invoked lambda, comma true, to get the, the true out of that so that we have the static assert. This nice proposal for C++ 2x, where we would be able to replace this immediately invoked lambda with const_eval. Anyone on that level? Yeah. Not surprised. Okay, but maybe in the future. Okay, so what we can do with the constexpr, what we actually care about it. It's important to be able to be correct, as pointed out in many talks. With the constexpr, we, to a certain level, are guaranteed not to have leaks. That will be because that will be not constant expression. It's more complicated with the standard library, but in the pure code, that will be the case. As well as undefined behaviors and some other things to the certain limit can be checked at compile time, and those things won't compile. Anyone on that level? Not a lot of people, because I haven't finished the talk and no one updated it. So let's go to even further levels. So static asserts are great, but they cannot actually verify the state that easily. So let's say we have a vector and we would like to verify the size. Well, static assert is not a constant expression here. Out of luck. What do? We fix it by putting a constexpr in front of that, because constexpr std vector is constexpr is 20. Well, that's not a constant condition either way, and we wouldn't be able to put things into that. So what do? We do an assert, and assert will fail because it won't be a constant expression, right? So we will get the failure in case the size won't match, otherwise it will pass. But the problem with that is that, well, it ain't gonna work with ndback because it will be gone away. And 2, it doesn't give us like static asserts can give us the values, right, on the error, and assert cannot. So what we can do, we can define a lambda which will fail, and by fail I mean we have a failed function which is not constexpr, and therefore it will fail in constexpr context. It still doesn't show the values, but at least it works in ndback. Anyone here? I am. So level 5, we can add sections to that. So we kind of get into catch territory. We can do the static assert. We can have the setup, section, tear down, and so forth. We still don't get nice error messages, but we're getting closer to that. We have to put a mutable on that. Not ideal, but we can do that. Therefore, I said almost all we need. But if you're on the next level, we can do even better. So with this one, it's a framework which tries to help us with that. By default, lambdas, they do constexpr. So there have been put a lot of effort in order to get error messages into the right state. So you can see here that at compile time, because this test will be run at compile time, and if it passes compilation time at runtime, we'll get the expect 5,3, which is a message at compile time. But if you just want to run the test at runtime, we just put mutable on it, and we get the runtime error message instead. This test won't be run at compile time. If you want to just run it at compile time, we can in C++23 put it const eval, and we add compile time. We can also put the flags to run it from the command line and runtime or compile time, but we also see here how many tests we run at compile time or runtime. Thank you.
Ooh, I'm gonna miss this. Okay.